Sure. The reason why I have a small intro session is some people are new to the class. Some people have attended a week's class, right? So why DevOps? That we will see, and what is DevOps and how we do DevOps. Three things. Okay. The basic functional teams in an organization, right? One is Dev. The other team is QA. Another important team is, can you name the team? The third one?
Prod.
No, operations. I mean, we are talking about only teams, not the environment.
Yeah, sorry, it is operations.
Okay. So functionally, there are three teams who does major work. Developer start writing the code, right? It could be for a particular module. So there'll be a high level design, and then low level design, and then it'll be modules. Modules will be assigned to people, assigned to developers, and the developers start working on the feature 1, feature 2, like this. So any doubts on this particular stuff? Anybody has any difficulties in understanding this particular responsibility for a developer? Okay, I'll go just one person. If anyone disagrees, do let me know. Balu, you have any difficulty in understanding?
No, sir. I'm clear.
Okay. So what is the next step after the code? Jeevan? After doing the code, what is the next step? Okay, see, I'll tell you. Unit testing, integration testing. But however, for this you require a build. Sometimes you don't need a build, you can just test it on your code base itself. Ultimately, after you do unit testing and integration testing, a kind of build is required. What is build, Srini? Any idea what is build? When I say build, what does it mean?
So, so it will be make executables for our whole application.
Correct. Yeah. It is like a bundle, right? All the packages, all the modules packaged together and then made it available as a binary or a bundle. Okay. So this is what usually a developer does, right? What are the things required for him? Anything? Definitely some tools, right? In order to build the application and make it executable. Correct? Anyone disagrees with this? Maven,
No.
Gradle, or depending on the application that you are developing. It could be more even Docker also. Okay. Any doubts with respect to the developer's responsibility?
So tools for the building, right?
Yeah, especially building and unit testing. Also some level of code analysis. Okay. Then moving on to QA right now. So what does QA does? What QA does? He writes test cases, right? Maybe he writes test plan also. So then what he does most of the times nowadays, everybody does automation in order to get the test cases tested automatically by just running automation scripts. what he ends up doing, he'll be creating a test report and bugs. Okay. Any doubts so far? Anyone? Balu?
No, sir, it's clear.
Sure. Kushal, anything from your side?
No, Shankar, clear.
So what he also requires, one thing in common, tools. Why tools? He has to decide whether um, I mean, there will be some kind of evaluation done within the team. They'll decide which tool will be good for the kind of application they're developing. For example, if it is a Python-based application, they will think about anything like PyTest or maybe other open source tools or maybe other enterprise tools for testing. Okay. What are the other responsibilities for a QA? Anybody who is working as a test engineer or who has idea about what is testing? So he will do system testing, and then they will do a regression testing. So these things will be called as functional. When you say functional testing, what does it mean? Ganesh? When you say functional testing, what does it mean? It is all about functionality, like whether login feature is working, whether registration feature is working, or cart, payment, like that. So any doubts with this? This is functional testing. What is other testing QA does? Any other clue? Anyone? Srini?
No idea.
Okay.
UI related things they will do.
UI related also you can say somewhat functional because that is not, which is very see we can add that also, that is fine, good. So non-functional testing, what do you mean by non-functional testing? Anyone has clarity on this? At least some basic idea. Atulya? It is load,
Yes, Shankar.
stress, performance. Why do we need to do this? Any thought process on that?
Uh, to for
Yeah.
consistent, whether the system is working consistently, like we can understand like how much you know, traffic or like load a system can handle.
Correct. So we wanted to just make sure whether system is reliable or not. Correct? And resilient. Basically, we wanted to test whether the application can withstand some kind of load and stress and things like that. For again, what does he require to complete everything? He requires tools. Okay. Now moving on to the operations team. So with respect to development and QA, we have done it almost. So operations team will just go further. Okay. What does operations team do? Anyone has an idea? So there are people like SRE, support, or incident management. These people will be part of the operations team, right? What they require, again, tools in order to make sure any P1 incidents, P2 incidents reported, how to solve them, how to create a new this one support ticket, and how to solve them. There is also kind of root cause analysis done, and we have a hotfix that is ready for the customer if there is a problem that needs to be fixed immediately. Otherwise, the issue will be reported and we'll try to solve that issue in the next release. Right? Anyone has any doubts on this particular part? Atulya, if you could probably add some insight towards SRE support or incidents, it will help others to understand better. Atulya?
Can you hear me?
Yeah, I can hear you. Yes.
Okay. So once developer build the code and QA tested it, and once it is available in the production, we will as an SRE or like in any operational person, we will maintain the system actually, whether the system is working, system stability. Okay. So SRE will be monitoring how that CPU utilization will be there, storage, whether if many load in the sense nothing but uh, so maybe there will be only 50 user can use at a time, for example it is okay. Maybe there are so many usages coming, whether the system is able to handle it or not, or whether the system, we will have a threshold thing, whether the system is going more than that, that will affect the system functionality. Maybe the system become slow, the latency will be there. So if there is any latency, what we can do according to that, what steps we can handle, or if customer is facing any kind of issue, they obviously, if we have any kind of issue, what we will do for our phone, in the sense we are not able to make a call, we will first check with the customer service what is happening, right? Same like that, every product will have an operation team who will handle the customer. So customer will call, and if the issue is not solved by the customer support, they will raise a ticket, and whoever is handling, like maybe it can be necessary or like technical support person, they will work on it. If they are also not able to handle it, then so there is a process which will go on. The main thing is that whether the system is working perfectly or not. So operations will be keep an eye on it, and they will work towards it. For any product, if you take any product, for a car also you have service center like that, right? So that is the main thing, maintaining the product,
Okay.
stability, functionality, etc. Yeah.
Sure. Thank you. So basically, we can call it as continuous monitoring because we are trying to continuously observe what is happening within the system after it has been released to the customer, because we need to be sure whether the customer is facing some problem or customer is okay. So all of those things we need to make sure. That's why we have operations team. They will ensure different team members involved to analyze the system, to observe the system. We also call it as observability. That is also called monitoring. Okay. So up until this point, anyone has any doubts? This is very, very important topic because this builds your DevOps career. Anyone has any doubts?
Yes, Shankar, one thing. So operations things, what is my concern is, for example, what are the tools are necessary for the testing people or other people? Developers may not be needful all those, right? So, tool maintenance is different for the, team wise, or how can these, operations guys will be segregate the tool installation sort of thing?
Yeah, see, definitely. Tool setup is something which is common for all the team, right?
Okay.
Sometimes a systems engineer will come into picture, or
Okay.
network engineer will come into picture, or any other system admin team will come into picture. When I say systems engineer, system admin also be part of it.
Okay.
So sometimes they will have a tools team separate tools team, they will do some POC. They will analyze whether this tool is okay, fine. Especially cost, also they will look at it. Licensing. So many things they will look at it. So it is again another topic of kind of, I mean, doing some kind of assessment within the organization, understand how much they can afford. For sure, every team here, if you look at it, so far whatever we have seen, tools is must, because everybody is trying to do automation, right? It is not like, I mean, you want to just do it manually and leave it, because people don't like repetitive tasks, and we know we want to be efficient and effective in our work. See, we don't want people to do some work, I mean, that can be done in an hour. They will do it for 2 days, right? Organization will definitely look for cost cutting, will definitely look for efficient work, efficient people. That's why everybody is focusing on tools. Okay, now going back to the first point, dev. Okay, when developer is doing development and then going ahead with feature development, doing unit testing and then creating a build, where he will test this application. So where he is supposed to test this application. Any idea? Is it on his laptop?
In a local environment, for example, if he is developing in mobile app, there is some interface like Android Studio like that.
So
Initially,
you said you require an environment, correct?
yes.
So we call it as dev, correct? So that is a primary thing for a developer in order to test whatever code that he has developed on his laptop. He cannot test everything on his laptop because it requires some kind of environment. Say, for example, like you said, if it is a mobile application, he requires an environment. In that only he'll test it. Clear? Is it clear to everyone?
Yes, sir.
Okay, sure. Now the next thing, QA does some testing. Does QA test everything on his laptop? Obviously not, right? Because he cannot do any testing on his laptop because it is only for some test case creation, test case automation, test plan creation, or bug reporting. So bug reporting is one of the primary tasks of a QA. Okay, then what he is relying on, he is also relying on a particular environment. That could be like QA or test. That is one environment. The next one would be stage, which is very much similar to production. Sometimes he requires extra environments in order to ensure non-functional testing are done. For that, he will require some stress test environments. Okay, and different team call it as different companies call it with a different name. So we will not go very deep into it. At least at a minimum, 2 to 3 environments he requires, QA person. In order to what is the purpose here? Purpose of QA? Validation of features. Validation of all the features. And also he will be doing some round of functional, non-functional testing. Okay. Any doubts so far?
No, Shankar.
Okay. So next comes the operations team. So what does operations team require? Some tools, and again he'll be looking at some of the environments. That is nothing but production. So he will also require a pre-prod, because not every time he can do the testing around or maybe do some validation around prod. So he requires some environments like pre-prod, so that he will have that environment and ask people to do some validation or some kind of monitoring on this also, so that anything whatever production customer is reporting, whether it is repeatable here, whether it is reproducible here, like that he will do some round of testing. Okay, what is in common for all the people? I'm going down now. What is in common for all the people within the organization?
Tools and communication between the tools.
Okay, tools first thing. So before tools, one more thing that is required: environment.
Neuron, yes.
When we say environment, what it is? At a basic minimum, EC2 instance if it is a cloud. So do you have this understanding? If it is a own cloud or maybe a data center, private data center, right? It could be a physical machine, or a virtual machine. Correct? Anybody has any doubts on this? Is EC2 a virtual machine? Srini?
Yes, sure.
You guys have a clear-cut idea of what is virtual machine, right? I mean, if not, please let me know. What is
Yeah.
virtual?
So virtual machine could be hosted in cloud or VMware
Right, exactly. So basically, it virtualizes your hardware, using a hypervisor software. So in that, you can create multiple VMs on your single hardware in order to make it efficient. One of the other purpose of creating a virtual machine. Can someone tell me what is the purpose of creating a virtual machine? The most important point, creating a virtual machine. Can you list few, Srini? Or anyone has an idea, please unmute yourself and then quickly tell me points. Okay, before that, yeah, please go ahead.
Yeah, by using virtual machine creating, instead of having in our physical things, we can create it immediately, and um, there is some useful things, right? Like whenever we are using, we can run and we can scale accordingly. There are some particular features for virtual machines.
Okay, you can do a scale. It is fast. Okay,
Yeah,
what is
we
a
can customize whatever the features we want. For example, if we want a 16 GB RAM, we can scale. If we want that much, we don't require. We can scale down to 8 GB. Whatever the installation we have, that is already pre-built applications are there to automate regular backups. A lot of features are there. Usually, by by creating a virtual machine, it will reduce maintenance things, etc. A lot of benefits are there instead of using the physical machines. That's why we went to virtual machine.
okay? So good, definitely the good points. So can you connect these pieces? Image, you require an image to boot an operating system, correct? You get it.
Exactly. Yes. Yes.
You get it fast because you are booting from the pre-built image, right? That image can be again built and then create another snapshot also. Whenever you require another piece of software, another piece of packages installation, you can create a snapshot and make it available. So image can be called as AMI in AWS, correct? Scale, when you're talking about scale, that is called as auto scaling group in AWS. When you say customize, right, the instance size and memory and all, it is like your instance type, like T2.micro, T3.medium, large, anything that you can choose, and then you can customize your resources. Okay. What is the other important thing by creating a virtual machine that we are achieving is consistent. Because every time you provision a virtual machine, it could be an EC2 machine or it could be a virtual machine. What exactly we are doing? We are trying to create the same exact copy of the same machine. There is no difference at all, right? Compared to even if you create multiple machines, M1, M2, M3, all of them will remain same. So there is no difference at all. So everything is exactly the same until unless you install some of the packages or configure something extra, it remains the same. That is one of the reasons why we are going ahead with the virtual machine concept. Consistency. Any doubts so far?
No, Shankar.
No, sure.
Any? Okay, sure, clear. Okay. Again, I'll explain a couple of other things, then we can take it forward. See, why virtual machine? We have already understood, right? Okay, can someone tell me why not VM? Just can anyone has answer for this? Complete voice and boot time. Boot time is like 3 to 5 minutes and less efficient. And more disk. Are you able to connect whatever I'm saying right now?
What is the last one? More this.
Yeah, I mean we end up usually using more disk space to install an
Okay,
operating
okay.
system
Got
because
it.
VM VM is all about the complete OS, correct? Even though we are trying to virtualize, we are installing the complete operating system. Hence, we are using more disk because the size of the image is almost more than 1 GB always. How much time it takes to boot up a virtual machine? Minimum 3 to 5 minutes. Okay, what is the solution for this? How do we resolve this particular issue? Containers. So why we are talking about containers is we are kind of little bit fed up with the complete virtual machine, which will occupy more space. That's why we don't want VM, and then we want to go with containers. What containers does? It can run multiple services on the single VM. You can say services 1, services 2, services 3. Like that, it can run multiple services. These are all isolated and lightweight. And it uses system libraries, packages, binaries of existing OS. It doesn't require a complete operating system. That's why it is lightweight, it is isolated, and it is fast. How fast it is? Few seconds to start a container. This also requires an image to build your container operating system. What kind of image it requires? If it is a Docker based container, it requires a Docker image. Okay, clear?
Yeah,
Moving
clear.
further. Okay, moving further. Why we need a virtual machine, or why we need any system? Anybody has a clarity on this? Say, why do we require a compute? In general, we call it as compute. That is to run a service or a process, and that will be called a server. That is kind of, you make it accessible to the customer. Correct? How do you make it accessible? You have a port which is running. You have IP address for this machine. You have a protocol for the particular process, a particular software that you are running, application that you are running. Using firewall, you allow or deny the incoming traffic. That is called the security groups in AWS. This is what is the whole intent of using a compute. So when we are fed up with VM, we are going with container. Container inside a VM or physical machine. Containers running on the physical machine or virtual machine. This is also nothing but services. Only difference is these services are running in an isolated mode. It has no direct connection with the other service which is running on the same machine. It is completely isolated. And you will have another system to make it available to the system, make it available to the outside people. Say, for example, someone is trying to access it. He may not have the direct connection to the services running as a container, but it has to be exposed to the host, so that customer can access it. The funda is only one extra thing is you have to expose this service to the host machine so that people can access it. That's the only extra thing that we need to do. That we will see it when we go to Docker containers, when we go to containers and Kubernetes, things like that. Okay. So by looking at all this, the first thing what a DevOps guy will do is create infra. Because we already seen environments like dev, QA, stage, pre-prod, and prod. These are the environments required. So pre-prod, people call it as UAT, user acceptance test. Stage is very much similar to production environment where you do all the testing. QA is only for functional testing, functional, non-functional testing. Dev is only for the developers to validate their features. Okay. So as a DevOps engineer, there are different responsibilities, but the primary responsibility for infra DevOps. So infra DevOps engineer will start writing code or he will create manually. So either this code is like an automation way or he can create manually on the AWS console. Automation way, we can use Terraform. Which one do you prefer? If you are following DevOps principle, what you are supposed to do? You are supposed to write automation code because DevOps talks about automation, collaboration, and communication. So first thing is automation. Collaboration is working with the different teams. Like I told you already, he'll be working with the QA, he'll be working with dev, he'll be working with operations team. In order to create infra and then install tools, getting all the people use same kind of tools, and then deployment. So all of these things is the primary responsibility of a DevOps engineer. Communication is more important because you need to work with multiple people. So you should have a better communication in order to even work with people, communicate what tools you're trying to use, what kind of infra that you're creating, how you're doing CI/CD. So next comes when you say everything is automated, you cannot really do a automation. I mean, you can really execute everything manually. You require a CI/CD system, CI/CD pipeline. Why CI/CD pipeline? Anyone has a quick answer for this? So we wanted to avoid manual execution. No manual execution. That is why we are trying to use pipeline. How you can make sure that there is no manual execution? There has to be some action. Based on that action, we should trigger some jobs. What is action? Push or merge. That is in Git. Git has different actions: add, commit, pull, all that, and then also push and merge. So for push and merge, will trigger the pipeline. For this action, will trigger the pipeline and execute the jobs in GitLab CI. And ultimately, we'll be creating resources or deploying resources in AWS Cloud. If it is infra, it is just only creating the infra, modifying the infra. If it is a application, you will be creating a build and going ahead with deployment for the existing environments. Okay. I would like to stop it at this point because this much theory is more than enough to understand the complete process of DevOps engineers. So any questions?
Yes, Shankar. Can you scroll up a little bit while starting the Docker thing?
Yeah, this one or
yeah, this is enough. See, Docker is installing under the VM, right?
correct.
For example, if we have some multiple, does it need some multiple VM instances? We have what what is the situation if we want to use multiple EC2 instances?
Exactly. So that will be our second step, or
Okay,
maybe
okay.
future thing. I'll quickly explain. So anyone else have any questions so far?
Yes.
That's a very valid question, because I mean we cannot just go with one single virtual machine, right? For running the container. What will happen again? What will happen again? Single point of failure. What is single point of failure? You're relying on one system. Even though you're running container, it may go down at any point in time, right? So you will definitely lose connection to this. You will definitely lose the customers, isn't it? Is it true?
Mm.
So that's why we need to have one concept called cluster, where we will run multiple virtual machines. So VM1, or you can say EC2. Okay. So in terms of cloud, you can say EC2. All these machines are connected together. Acts like a single machine. Acts like a single machine. How you can make it act like a single machine? You will have a load balancer connected, call it as application load balancer, and we'll have a domain connected to the load balancer. Domain is nothing but Route 53, which provides DNS. The customer who is accessing, he will know only Amazon.in. He doesn't know what is a load balancer here, what is a load balancer here, what is the number of services running in this EC2. Inside all these machines, virtual machines, there will be containers running.
Yeah, okay. So here, I mean, in one virtual machine, we need to create a container things. Every machine, it will automatically create that container.
Yeah, again, so that's again advanced concept. For
Okay,
sure,
okay.
we'll be running multiple containers on multiple virtual machines, because in order to manage the load and performance.
Got it.
Okay, clear?
Yeah, clear, Shankar. Thank you, sir.
There are three important concepts in cloud. One is highly available, highly scalable, fault tolerant. For highly available, we have availability zone, that is AZ1, minimum AZ2. Highly scalable, we have auto scaling. Auto scaling will happen based on the utilization. So it will increase or it will decrease based on the requirement. So scale up, scale down is possible. Fault tolerance, that is using load balancer, that will decide anything faulty which is not working, which will redirect to the working one. So it will have some mechanism like health check, and if the health check is okay, then it will forward the traffic to the particular instance. Otherwise, it will not forward the traffic to the other that particular instance. So we have something like auto scaling group for this. And for this availability zone, you already know it is availability zone concept. Okay. Any questions so far?
From my end, no, Shankar.